Hello guys, welcome back to my channel. Mason African Motives. Still working on A-level mathematics, that is a pure mathematics. In this platform, guys, we shall focus actually on transformations, that is how to transform graphs for the first part, that is the first section that we have, mostly for the lower part. So we shall just quickly rush through this part. So if you're new, guys, you can consider being part of the family Mason African Motives by subscribing, so that you won't miss any of the classes that you shall be having from this platform that we have, and also to invite as many friends as we can, so that we can also grow as a family, so that we can offer as much stuff as we can as we grow as a family. Anyways, guys, let us quickly rush through this particular section. So like I said, I'm just going to try to just wrap one or two of the confusions that we have whenever we are working with functions, transformations. You'll be given a consideration, let's just say in this case, because transformation it's in many ways. Okay, I'm having a function of x definitely that I want to transform. So this is going to be whatever, a straight line, which is a linear function, a quadratic, a cubic, whatever function that you have. You transform this to a certain function. Let's just say it's now maybe hx. Okay, so this will be your object function. This is the object function, and this will be your image function. That is where we have transformed this line to, or this shape, or whatever that you have to. So we have got transformations that we have where we can actually shift the line or shift the shape. You can actually shift the shape upwards, or you can shift this shape downwards, which is actually a translation. Or the shape can be shifted to the left, or it can to the right, or it can be shifted to the left. So that is a transformation that is occurring, which is let's take example that I'm having. Let's just say this line here. Okay, this is a Cartesian plane that I am having. All right, I've got something like this. All right, this is a line, just a normal line, and this point is -2, and this point is 2, and this is 0, which means this is -2, 0 here, like this, and this point is 0, 2, like this. All right, let's say I want to transform this graph. Maybe I want to transform this graph 2 units to the right. All right, 2 units to the right. What is going to happen is that each and every point is going to move 2 units to the right. That is, this point is going to move 2 units. It's -2. That's -1 here. So it's going to move 1, 2. So I'm going to see the image at this point, which is now at 0, 0, which is the origin. Okay, I want to transform this point, so it's going to move. This is 1, 2, 3. So this is at 0 here. I'm going to move straight. That is 1, 2 at this point. So this point is going to be like this, and the image of the line is going to be like that. So what you need is to know the transformation effect. Is it a translation? Is it a reflection, and so forth? Okay, so I'm just going to summarize this in a tables. Like in fact, I'm just going to explain the tables. There's a lot of things that we have, but if you have got this table, I think it can help us. Guys, let us just, all right, put it this way. All right, so let's say we are having, these are some of the very, very useful transformations that we have, that we are going to focus with. Let's say the first part here, where we are given f of x plus a. That is a translation. You are adding to your f of x. Okay, your f of x is the original function. Then if you add a, that is maybe let's just say your f of x is just a function of x. Okay, then it means f of x plus 2. Each and every point is going to move 2 units upwards. That is a transformation that we are referring here, a units upwards. So it can be presented by a column vector, which is the vector for translation, which is 0a. All right, when it is a minus, it means it is going down. All right, that is a unit downwards. But take note, when you write it as f of x minus a like this, maybe it's a transformation of f of x minus 2 like this. It's a translation, but this time what you do is that you're going to equate this to 0. X minus 2, you equate to 0. So x is equal to 2. So that means it's a positive, that is 2 units to the right. So when it is a minus like this, it means this is 2 units to the what? To the right. All right? Or 2 units parallel to the x-axis. That is, you're going to the x-axis like that. That is okay, that is f of x minus a parallel to the x-axis. If it is a plus, which means it is going to be a units to the left, which means because it's a minus like this, maybe you've got f of x plus 2. If you equate this to 0, x is going to be minus 2, which means that's 2 units to the left. It's a minus. All right, minus f of x, that is a reflection, okay, which is in the x-axis. So we need to know is the reflection, and when it is f of minus x like that, it's a reflection, but this time in the y-axis. All right, which means you multiply the x values by a negative, like for the values that you have. This time you multiply f of x, this is y, so you multiply the y values by what? By a negative. Okay, I'm going to explain all those, and a stretch where this time you divide each and every x coordinate by what? By the number that is affecting x. But for this one, you divide each and every value of y, that is you multiply, because this is ay like this, ay, so you multiply this one, but here you divide, because remember the concept of equating to 0. So here you have to divide so that you remain with x. So these are the transformations, guys, that we are going to at least focus on and see how the questions will be given and how do you apply these typical transformations on the questions. Normally how they ask the first particular type of a question, like the one that I was explaining, is that they can give us let's say this type of a question here, where we are given that there is a graph of y is equal to f of x, which is shown below, and this is the graph that we have here, which is shown with the points a, b, c, d. So this is your graph here, and we are given the points a, b, c, d, and this is our point a respectively. So a is 0, 1, so that's our 0, 1 here, and this is our b, which is 1, 0 here, and this is our c, which is 2, 1. Okay, guys, don't mind, because this is supposed to be like in the same line with this, okay, because it's 2, 1. Okay, just don't mind this diagram. And the d, which is 3, 0. So these are the points that we are given. All right, now the question is, sketch separately the graphs of, we want to sketch separate the graph of a, y is equal to f of 2x. All right, stating in each case the coordinates of the points corresponding to a, b, c, d. That is the ones that are corresponding. This is from the question paper, guys. This question is actually from one of the question papers that I just took. So what we have, guys, is that we want to transform. This is our first transformation, all right, which is f of 2x. Okay, y is equivalent to f of 2x. This is the function that we want to draw from the one of y is equal to f of x, which is originally given here with these coordinates. Okay, so we said when it is a transformation f of 2x like this, which one is it going to match now? So all you need is to know your transformation, guys. As you can see, this is the one that you're talking about here, f of ax, where I told you that here you divide the x values by what? By a. That is a stretch that is parallel to the x-axis of stretch factor 1 over what? 1 over a. So you divide x coordinates by what? By a, which is your a in this case is 2. So we are going to divide x coordinates or x values, let's just say x values, by 2. All right, so we had the first point, which was a. Our point a here is 0, 1. Okay, that's our point a, which is 0, 1. So if we divide the x coordinate by 2, this is your x coordinate, so which means our image, let's just say a1 is our image. If we divide this by 2, there's no change, it's just going to remain as 0, 1. So which means a is not going to change in this case. All right, let's move on to b. Our b was 1, 0. In this case, this was 1, 0, like this. So now the image of b1, you divide the x value by 2. This is your x value, which is 1. So 1 divided by 2, that's 0, 0,5. So it will be 0, 0,5. The y values, they remain as they are. Y values, they do not change. All right. Your point C, this is your point C, which is 2, 1. Okay, that's your point C, which is 2, 1, like this. You divide the x coordinate by 2. That's 2 divided by 2, which is 1, 1. The y value does not change. You move on to D. You do the same as 3, 0, this one. Okay, this you divide by 2 here, which means your D1, which is the image, is going to be 1, 0,5. 0, like that. The value of y, remember, does not change. So these are the image points that we have on a transformation of y is equal to what? To f of 2x. So now your sketch, so maybe okay, let me just do this one. Let me just sketch it separately. I'm going to like have this as your original, then a sketch aside, so that we can see the actual effect of what happened there. All right, so this is it, guys. It's going to be like this. This was our original sketch, so I'm just going to start with the original sketch. All right, this was our original sketch, guys. It was like this. All right, so let's correct that point that we said it must be in the same line, so it may be somewhere here. All right, so let's just correct that one so that it will be in the same line, the one that we wanted to correct. Okay, this was your A, and this was your B, this was your C, and this was your D here. All right, now we have got new points, guys. Our A is going to remain where it was because here there's no effect, so which means it is going to remain, let's say, here. All right, then our B is now at 0, 0,5, 0, which is, this was your 1. 0, 0,5 is maybe somewhere here. Maybe this is where we have got our B1. Okay, our C1 is going to be 1, 1, which means it's now at B, where it could direct at B here, but it's now 1, 1. Remember, this is 1, so your C is going to be at 1, 1. Maybe this is your C, 1, 1. Your D is going to be at 1, 0,5, 0. So 1,5, remember C was 2, so which means 1,5 is somewhere here just below C. This is where you're going to have your point D now. So the image line, guys, is going to be like this from this point A. So your graph is going to be like this from point A to B, from point B to C1, and back to D1. So this is what your image line is going to be like. So this is your C1, and this is your D1, this is your B. So this is the image that is, so as you can see, that's a stretch which is occurred to this line, to this particular function that you had. All right, so this is how you just work out with this transformation, guys. So it means if my question was, I want to have a y is equivalent to f of x plus 2, like this, what does it mean, guys, from the concept that we talked about? If it is now f of x is y is equal to f of x plus 2, it means I have to add, this is a translation of 2 units upwards. So each and every point on y is going to move 2 units upwards. This is what we had here, f of x plus a, translation a unit up, which means if it is a unit up, you are going to add a to y values. Okay, so you add a to y values, which is your a, because it's going up. So which means each and every point on my graph that I had, I'm going to add a 2. I'm just saying, if it was like that here, I'm going to add each and every point, so which means just like what I did. So it's going to be 1 plus 2, which is at 3. So this point is going to be at 0, 3, which means somewhere here at 0, 3, this will be your a. This point you add 2 2 to the x value. This is what? 0 plus 2, which is 2. So it will be at 1, 2, at 1, 2. Maybe it's somewhere here. Okay, that's our 1, 2. C is going to transform. Remember, C was somewhere here. So C will correspond to, which is at 3, which is at same point at A there. Then your D plus 2 here is going to be 3, 2, which is 3, 2, which corresponds at this point somewhere there. So which means our sketch is going to be like this now, to point this point at B, to this point, then to that point at D, something like that. So whatever transformation, it affects in its own way. All right. So let's see the other transformation. What we had, this was f of x on B, f of x plus 3. So what is going to happen if now we are going to work with the transformation of y is equal to f of x plus 3? So from our transformation, we said this one, we equate this to what? To 0. So x is going to be minus 3. So this is a translation of 3 units to the left. So we're going to move each and every point 3 units to the left. If you are to cross-check, this is the transformation here, f of x plus a. We say that's a translation of a units to the left. All right. So each and every point is going to move 3 units to the left. That is, we are referring to this. So if it is moving 3 units to the left, so I'm going to affect what? The x values. In this case, we are affecting each and every x value. You subtract 3. Okay, so this point is going to move. So our sketch is going to be like this, guys. So all you simply have to do, okay, before we talk of the sketch, let's just maybe have the point. So the concept is that we said our x is what? Our x is minus 3. So this is x. So what it means, you are going to subtract 3 from each x value. From each x value. All right. So just like what we did from that previous question, guys, our a, remember our a, we said it's 0, 1. So it means the image of this a is going to be maybe a1. We subtract 3 here. So this is your x, this is your y. So it's 0 minus 3, which is, it will be now at minus 3, 1. Okay. Your b was at 1, 0 here. This was your b at 1, 0. So you subtract 3 because it's minus 3. So it's 1 minus 3, which is minus 2, 0. So this will be your b1. Your c was at 2, 1. So this was 2, 1. You subtract 3 on x from x. So it's 2 minus 3, which is minus 1, 1. So you're only affecting x. Y remains as it is. Your d here was 3, 0. This was 3, 0 here. So if you subtract 3, that's 3 minus 3, which is as 0. 3 minus 3, that's as 0. So it's going to be 0, 0 like that. So these are the coordinates of the image when we have transformed with the transformation of f of x plus what? Plus 3. These are the new coordinates that we are going to have. So that means this point, we said it will be a1 will be at minus 3. So let's just say this is minus 1, minus 2, minus 3, 0, 1, 2, 3. Okay, this is 1. Let's just say, guys, this is 1, 2, minus 1, minus 2. So our a is going to be at minus 3, 1, which is minus 3, 1 somewhere here. This will be your new point a. All right. Okay, let's just mark the points. Actually, your b will be minus 2, 0, minus 2, 0 here. That's your b here. Your c will be minus 1, 1. Your c will be minus 1, 1, which is here. And your d will be 0, 0. So this will be your d, which is 0, 0. But the shape is going to remain as it was. Remember the shape that you had, this type of a shape, it must remain as it is. So it's going to be from this point, right, to this point at minus 2, to the point at c, then to the point at d, like that. So the shape is going to remain as it is. So this is your a, your b, your c, and your d here. So this is your new image now with the new coordinates that is from that part. So guys, a transformation, you simply apply the given transformation. So that was the case that we had here. So this is from one of the question papers, like I said. So when you are given these typical questions, I want you to apply this same concept And with the help of this table that I have given you, you can start by working with the table, but as you go on, you'll be able to understand each and every transformation. Without this table, you'll be able to know them, all of them. So I need you to work on this so that you know all of these transformations. Okay, anyways, there is another particular type of a question now where you'll be given to you are the one now who is to describe the transformation which has occurred. Okay, you are the one who is to describe the transformation that has occurred. Let's say let's say originally we have got a graph of y is equal to f of x. All right, let's just say 1 over x, or it can be whatever function, maybe y is equal to x, then there are certain transformations. Okay, so but I'm going to start with this particular type of equation. Let's say this is your original function or your original equation for the graph that you're talking of in this case. Then you transform this graph into y is equal to f of x, which is now a new function. Maybe it's given by this a plus b over x plus c. Okay, let's say you have transformed this graph here into this graph. This is the original and this is the image line. This one is your image line or your image function. The question is going to ask you now to describe the transformations which has occurred from this to this function, or which can be applied for us to have this function from this function. What are the transformations that is occurred? Okay, so these are the transformation. As you can see, your 1 over x, this is your 1 over x here. So all you need is to locate that 1 over x from the image equation, which is, let's say that this is our 1 here. So 1 over x is this one. This is your 1 over x. All right, so it means there are 3 transformations which have affected this function, because from 1 over x, just look, there is now a, there is now b, there is now c. So these are the transformations that you are supposed to describe. So this a here is referred to as a translation, because it's just added to the function, just like f of x plus a, this one, f of x plus a. Remember, we said when you just add a to a function, it's a translation. So a, this one is a translation of a units. This is translation of a units parallel to the what, to the y-axis. It's either you're going up or down. So this is going up or down. I don't know, because it may be a negative or a positive. If it is a positive, it goes up. Negative, so this is positive, negative. All right, then let's move on to b. What is this b representing? Okay, the b is referred to as a stretch of vector b. So this is a stretch of vector b that is in y-axis or parallel to the y-axis. In what? In y-axis. So that's how you describe this. And the c, this c here, it depends if it is x minus 3. If it is x plus 3, as long as it affects x, it's going to be, you equate this to 0, x is going to be 3. From this one, x is going to be minus 3. So this one is a translation also. So that's a translation that you're going to have of c units. This is a translation of c units, but this time it's in the horizontal. In the horizontal. So I'm using this as a branch name to say in the horizontal, because it can be to the positive, which is to the right, or to the negative. So if this is a plus, it means to the left. If it is a minus, to the right, because you're going to equate a plus changes to a minus changes to a plus. So that is the concept. So the question now is, are you going to be given the equation like this direct? That's the question. Yes, in some cases you might be given that like that one direct, but in some cases you are not given a direct equation that you simply start by explaining. No. They will give you something like this. they will give you something like this. This is the type of equation that you'll be given. The function of f is defined by, that's your f of x, which is 2 minus x over x plus 1, where x is not equivalent to minus 1. From this function, express f of x in the form of, this is the format. Now, as you can see, this format here is this format that we have got here. So how are you going to achieve this format from this fraction? That is the question. So there are so many ways that you can do this, but I'm going to work this with the long division concept. Then after that, you're asked to describe the transformations. Okay, so this is what we have, guys. We need to write 2 minus x over x plus 1 in this particular format. All right. So this is how you can achieve this easily. You can simply do this by long division. All right, you applying long division. So what is long division? How do I apply long division? I simply divide, okay, by x plus 1, this term here, which is x plus 1 into this term of 2 minus x, of which 2 minus x, guys, is same as what? Minus x plus 2. So I can write this as minus x plus 2. So I want you to follow this concept. You understand me? So this is your long division. This is how you do it. You divide always the first term versus the first term. So you divide first. So it's minus x divided by x, which is what? Minus 1, because this will cancel. The number that you get here, you multiply it back every term on this part. So this minus 1 here multiplies everything back here. So it's minus 1 times x, which is minus x, minus 1 times, this is a plus 1, which is going to give us minus 1. So you multiply back everything. Then after doing that, you subtract. So it's divide, multiply back, subtract. Then you redo this. Okay, so that's the concept. You keep on doing this if it's possible for you to do that. Okay, so here it's minus x minus minus s. You can see it's a plus here, which is gonna cancel. This will cancel, which is a 0 here. So it's 2 minus minus 1. So minus and minus, that's a plus. So 2 plus 1, which is a 3. So I'm going to obtain 3 in this case. Okay. So what does this mean if I have divided? Because as you can see now, it's impossible for us to say 3 divided by x. We can't do this. So which means this is our ending part. This way you're going to end. But your answer now, it means this part, this is what you were dividing. So when you divided 2 minus x by x plus 1, you obtained, what did you obtain? This is your exact value that you obtained. So you're going to write this as minus 1 plus this here is your remainder. This one, this is the remainder that you obtained. So it's the remainder over the denominator, the one that was dividing, which is x plus 1, which is what? This denominator here, which is x plus 1. Take note, guys, this part that we are referring to in this case. We have to be very, very careful with this part that we are having. So we say this was divided into this expression how many times? From this part, how many times have we divided? That is what is important. That's minus 1, and we've got a remainder of what? A remainder of 3. All right. So this is the format, which is this way that they are asking you to write like this. In this format, a plus b over, which is your a, your b, and your x plus 1. So this is what you're talking about. Then once you have this format, hence, which means from that continuation, give a sequence of 3. There are 3 transformations which occurred, which take the graph of y is equal to 1 over x. So you have to locate that graph from this format. You can now locate 1 over x onto y is equal to f of x, which is this one. Okay, so what I'm simply saying is that if we are to locate here, this is here 1 over x, we must locate. So we just put this as 1 over x like this. So these are the 3 transformations occurred: minus 1, 3, and this one. So these are the 3 transformations which occurred. So now let's just describe our transformation. What does it mean? This minus 1, what does it mean? We said when it is a from this part that I explained here, your A represents a translation of a unit either going down or up. It's a negative, so it is going down. So this is a translation of 1 unit downwards. So we are going to have, these are the transformations now. So we've got translation of 1 unit downwards. That is downwards, or parallel, -1 parallel to the y, something like that. Okay, then we said this is our b, which is our 3, which we said our b here, it's a stretch of vector b in the y-axis. So this is a stretch of vector 3. So we have got a stretch of vector 3 in y-axis. All right, then we have got this x plus 1, where I was saying if it is a plus, it means it's a translation that is to the left. When it is a plus, it changes to a minus, which means it's going to the left. So that's a translation of c units in the horizontal. So a plus 1 like this, you equate this to 0, just like what we did previously. So x is -1. So that's a translation of 1 unit to the left. So this one, we've got a translation of 1 unit to the left, or -1 unit parallel to the x, like that. So guys, as you can see, for you to describe this transformation, you must be able to know this format. Once you know this format, it means the description is now easier, just like that. So these are the typical questions that you shall have. So all I want you to do is now to try this one, where you are given this just like the previous question. So all you need is to do your long division, describe the geometrical transformations required to obtain the graph of f of x from. So like I said, guys, all you need is to locate this from that format. So you need to have that format first. So you do your long division first, then you can be able to describe. Okay, so I want you guys to try this question, work on it, and see if we are going to win from this part. Okay, so it's the same thing that we have got. So I'm just going to work on this one. Maybe let me just do this one, where we are given to describe completely the two single transformation which maps f of x, which is 1 over x, onto this. So like I said, guys, the first thing for us to locate 1 over x, do long division. So we've got 3x minus 5 over x minus 2, like this. So using our long division, it's going to be x minus 2, which is into 3x minus 5. So this is 3x minus 5, like this. So this is how you divide, guys. I told you the first thing is to divide. So it's the first term versus the first term here. 3x divided by 3, which is what? Which is 3. This 3 multiplies back each and every term. So it's 3 times x, which is 3x. 3 times minus 2, which is minus 6. So then you subtract. Okay, so that is the case. Divide, multiply, then subtract. Okay, then you are going to subtract 3x minus 3x, that's a 0. Minus 5 minus 6. So take note, it's minus a minus, which is a plus, like this. Minus plus 6, like that. So which is going to give us a 1. So this is your remainder, and this is the exact value which was being divided into. So it means this, my 3x minus 5 over x minus 2, can be written like, here I've got 3. So it's say 3, this one. So this is 3 plus the remainder now. So this is the exact value, which is 3. Then you add the remainder over the part that was dividing. So it's over 1 over, which is our remainder, over x minus 2, like that. Okay, so this is what is equivalent to this, your f of x. So now let's locate our f of 1 over x. So as you can see, 1 over x, already here there's a 1, so it's going to be 1 over x, like this. Already is a 1. It's not 3 or 4 like what we had. So that is why they say 2 transformation, because we only have 2 transformation, this one and this one. These are the only transformation which occurred, because 1 over x, this one, this is originally 1 over x, so there's nothing that happened. But if there was a 4, it means there's a transformation there, but this one is just 1, so there is no transformation which happened there. All right, so this one, let's describe this. We say this one is a translation. So we are going to have a translation of 3 units. So this is translation of 3 units. This is a positive, so it's going up. So we can just say upwards. All right. Then here it's x minus 2. So if it is a negative like this, you equate this to 0. So x is equal to what? To 2. So it's a translation again. This is a translation of 2 units. But where are we going in this case? This is to the right because it's now a positive. So this is to the right. So that's how you simply describe. So you can even describe with the vectors. This one you can describe with a vector. It will be 0, 3 like this. This one as a vector, it will be 2, 0 like this. So you can even describe with the vectors. The transformation, guys, a lot that you can actually have or that you can do. Okay, then another typical type of equation is when you transform a certain function, then it may be you're given y is equal to f of x. It's a quadratic expression that you're going to have, or maybe y is equal to x squared. Then it's transformed onto y is equivalent to a into maybe it's bx minus c, let's just say squared, plus d. Normally it's supposed to be a into x plus b squared plus d plus c, like just like this. Okay, so like this, guys, when it is like this, it's just a here is going to represent a vertical stretch. So this will be your vertical stretch, which is a stretch factor of 2, stretch factor of 3, just like that. Okay, this b here is going to represent a horizontal stretch. That's a horizontal stretch. Okay, so take note when it is like this, but when it is like this, which means this b here is going to be different. So okay, it's going to be different. Okay, this c here is going to be, because it's affecting x inside, like x plus b, x plus c. So this one is a translation. Okay, that's a translation that you shall have, but remember always you equate this to 0. Okay, so it's a translation, this one, which is a horizontal, actually, that is in the horizontal, in the x-axis. Okay, then d is also a translation, but this one is either it's going up or it's going down. So it's a translation in the vertical. This is a translation in the vertical, as we know that is either it's going up or it's going down. So for you to achieve this format or this format, we know something that is to do, or that is to play around with completing of square there. Remember, guys, you're completing of square there. You have to know something. Okay, anyways, I'm just like explained, telling you what it's supposed to be like. Sometimes they just give you this direct question like this one. It was actually a direct question where you're given to describe the transformation which maps y is equal to x squared, okay, onto this function. So as you can see, the 3 transformation is this one, and the x pos, this is your x squared. So inside here there's x plus 3, and this your minus 1 was added. So these are the 3 transformation that we shall describe. So we say this our a here like this, that's our vertical stretch. This is your a here, so it's a vertical stretch. So we've got a stretch of vector 2. So this one we are going to have a stretch of vector 2 that is in y-axis or parallel. Okay, in y-axis. The number 2, we've got this a translation, but it's x plus 3. So x plus 3, equate this to 0, which means x is equal to minus 3. So this one is going to be a translation of 3 units. That is a 3 units to the left, because it's going to give us a negative, and this one is a negative, but it's added to the function, or which means it's going down. So this is a translation of 1 unit. This is 1 unit downwards. All right, it's going down, this one. All right, just like what we said here, the d here is a translation in the vertical. So vertical, it's either going up or down. So if it is a positive, it goes up. If it is a negative, it goes down. So that's the guys, this is how they just ask these questions and so forth. So this transformation, they can even extend not only on this algebraic part that we are talking of here. They can even be given like this one from one of the question papers. It was actually a sine function like this. So you just apply the same knowledge, guys. It's one and the same thing. What is happening here? Describe the transformations needed to transform the graph of y is equal to sine x onto the graph of, this is the graph that you're given. So take note, all you need is to locate your sine x, which is this one. So what happened? As you can see, there's a 6 here. There's this 2x. It was sine x, but there's now 2. So there's a transformation here. There is a minus pi, which is involved there. So which transformations are you talking about? The 6, definitely. This one is a stretch, as usual. So you've got a stretch here of vector 6, okay, as usual, parallel to the y-axis, guys. All right, let me write parallel to the y-axis, like that. All right, then what else do we have? We've got the 2x. Remember from that table that we had there, if I am to show you the 2x, when it is written like this, 2x, like ax, we said it's a stretch again. So it's a stretch, but its factor is going to be 1 over a, so it's 1 over 2. So this one, we have got a stretch again, because it's multiplying. This time it's not 2 plus x or x is 2x, it's multiplying, so it's a stretch. So you need to locate all this. So it's a stretch of factor. So this one will be of factor 1 over 2. You divide by you divide this 1 over this value that is affecting x, which is 1 over 2. So it's a stretch of factor 1 over 2. This one is parallel to the x-axis, this time parallel to the x-axis, because it's affecting x, parallel to the x-axis. All right, what about the minus pi? As you can see, this was your original function, then you just subtracted pi. To subtract or to add, it's a translation. So this one is a translation. But how is it affecting this translation? So this is a translation of pi units. Is it going up or down? It's going down because the negative. So this one, pi units downwards. So you see how you describe these transformations. So this is how you simply describe the given transformations. All you need, guys, is to know the basic. To say my original function was just sine. Take note, sine x. Now I multiply this sine x by 6, then also multiplied by x, then subtracted another. So this is your original. So what happened? You locate the adjustments which were done. Those are your transformations. Then you relate back to your table to say which one is the best that I'm going to use there. So, but those are the typical questions that you also have. So another one is actually I want you to work on this one. Just try and see if you're going to, but I've explained this, so I just want you to work also on it. Describe the two transformations that you're going to map. I talked about. So this one, you have to locate 2 over x this time. So you have to locate 2 over x. So 2 over x, that means that is your original part. Okay, so they are going to be 2, which means something is going to remain with 2 over x there. Something is going to remain with 2 over x. So I want you to try this one. Feedback, guys. I need the feedback so that we will know that we are actually moving together or not. All right, describe completely. That's another type of a question here that you are given. So as you can see, guys, all you need is to locate your e to the exponent of x, which is this one, e to the exponent of x. So what is done? 2 is multiplied to e. So this one is a what? It's a stretch. So we've got a stretch here, a stretch of vector 2. This is what in y-axis or parallel to the y-axis. X, guys, whenever you see x added or x subtracted, guys, take note about that. You equate this to 0. So x minus 1 is equal to 0, which is x is equal to 1. So it's a translation, this one. So that's a translation of how many units? 1 unit to the right, because it is going to be a positive. Negative changes to positive. Okay, then this one also is a translation, which is a translation is simply a shift of 1 unit, a shift of 3 units. It's one and the same thing. So this one is a translation of 3 units upwards, or a shift of 3 units upwards. Simply one and the same thing. So that's what you have there. So you can just work on it as much as you can. What about this one, guys, which is going to be our last particular question? So all I need is to explain from it. This one we are given from one of the question papers. Also, this one is from one of the question papers. I'm just going to explain this one, where we are given to describe completely the three single transformations which maps y is equal to 1 over x squared onto that particular function that we have got there. All right. So it's very, very difficult for us to locate 1 over x squared like this, guys. So all we need is to at least expand this. So we are going back to our long division. I think I talked about the issue of a fraction, the issue of long division. So as long the numerator here have got the same exponents, or if the numerator has got a bigger exponent than the denominator, do long division. So what are you dividing? This is the one that we are using to divide, which is x squared plus 2x plus 1 into this 3x squared, whatever that you have, which is 3x squared plus 6x plus 7. So whether it's a quadratic like this, guys, the concept is the same. Like I said, you divide the first term always versus the first term. So this is your first term and your first term. So 3x squared divide by x squared, that is what you're doing. So this will cancel, you remain with 3. 3x squared divided by x, which is going to give us 3. This 3, I told you, it multiplies everything back, everything here. So it's 3 times x squared. That's 3x squared. 3 times 2x, which is 6x. 3 times 1, which is plus 3, like that. Then whatever that you have after dividing, you multiply, then subtract. So you're going to subtract DMS. Okay, so that's it, guys. 3x squared minus 3x squared, that's a 0. 6x minus 6x, that's a 0 here. 7 minus 3, which is 4. So this is our remainder here. This is our remainder. So it means this whole part that we had divided, guys, the 3x squared plus 6x plus 7, that we divided by x squared plus 2x plus 1, like this, it is going to give us, it's going to be divided how many times? 3 times, and it gives us a remainder. You add the remainder, a remainder of 4 over what was dividing. We were dividing by x squared plus 2x plus 1. This is what we're using to divide. Now still we are having a complex question, because here we've got x squared plus 2x plus 1, and it's difficult for us to locate, because all we need is to locate this 1 over x squared. So how are we going to locate it? Okay, this is what is going to happen here. If you are to check properly on this expression that you have, I want you to factorize and see what is going to happen here. We are going to remain with 3 plus 4 over this part here. If we are to factorize, guys, from your factorization, remember the equivalent of x squared is 1. So all you need is to open 2 brackets. We've got x here and x. Focus with 1. What are the factors of 1 which you are going to add? And they'll give us 2. So that's simply 1 and what? 1 and 1. 1 times 1, that's 1. And if we add 1 plus 1, that's 2. So these are the factors that we have got. So it's x plus 1, which is just like 2 times 2. We know that this is 2 squared. So x plus 1 times x plus 1 is same as what? X plus 1 squared. So now we can easily locate our x squared here. All right. So this can be written now as x plus 1 squared, like that. So if we can be able to locate our 1 over x squared, which is going to be achieved from 1 over this x squared, it means the transformations which are now affecting here is this. There's a transformation here, this 3. There's a transformation here of this 4. There's a transformation inside, because it was just supposed to be x, but it's now there's x plus 1 there. So what are the transformations? These are the transformations that we have. These 3. So what about this 3? What is it representing? So this 3 is actually a transpose. It's just adding to the what, to the function f of x plus 3. So it's just added. So this one we are having a translation of 3 units upwards. Okay, because it's adding. So this is going to be upwards, it's going up. All right, then here we've got a 4 here, which you said this one is a stretch from your presentation that time that I explained. This one is a stretch of vector 4. So this is a stretch of vector 4 vertically, okay, in the vertical, that is in the y-axis. All right, we've got x plus. Whenever you see x plus, guys, translation, I think now we are used to this. So x is equal to -1. So this one is a translation of 1 unit. So this is a translation of 1 unit to the left, or -1 unit in the x, or a shift. A translation, like I said, it can be represented as a shift. So guys, that's what we had actually from this platform, working on A-level mathematics transformations 1. That is the first part that we have. We shall meet again sometime, working now on transformations and other topics, paper 2, and for the second part, working with matrices and so forth. But for the meantime, that's what we had, guys, from Meson African Motifs. Till we meet again.